Hello, we are Solene and Carla from the IOGS, and we worked during 5 sessions on a project for Hermes concerning the analysis of the shine of leather sample. I will let Solene present you the context and problematic we tried to solve.
So what is the context of our project? In fact, Hermes sent us 21 samples of leathers that have different grains, different smooth and gloss, and we have analyzed them in order to do a classification from the most matte sample to the most glossy ones, and with a gloss scanner system, because there is a gloss meter, which is an object that can give us some values, but it is only for smooth surfaces, because the second one and our leather sample are irregular surfaces. So we had not like conclusion on it with just the gloss meter. So the problematic of our study is how to classify the gloss of Hermes leathers with the gloss scanner system that Carla is going to present you just after.
So to obtain the classification, we had at our disposal a gloss scanner made up of LED in front of the leather sample, and a cooled camera placed behind and above the sample and aligned with the sample. So the LED was piloted by an Arduino code, which allowed us to make the LED moves step by step to take picture at each stop with the camera. The choice of the lens between each stop was very important to be sure to well sample our problem. In this way, we could be sure to make enough stops with the LED to take enough pictures with the camera. So after having properly set the movement of the LED, because it had to slightly exceed the border of the sample and to stop a number sufficient of times, there remained only the capture of the images. So you can pass a little bit. So we chose a region of our sample, made the LED move, and took a picture at each stop to collect the intensity as a function of the translation of the LED. And then on MATLAB, for each sample, so for each series of images, we took a small zone of pixels, approximately at the sample, at the center, and we calculated the mean pixel value of this zone, and then we plotted each for each position of the LED, and it leads us to the following plots.
So thanks to our work in progress, we were able to draw these different graphics. So on the first one, we can well see that the most spread out and the lowest curves are represented the most matte sample, whereas the most intense and sharp ones are represented the glossy samples. So then we calculated the second derivative of each Gaussians in order to have their widths, the peak widths, and to classify them and to do the classification that was asked by Hermes in order to classify all these samples. And we drew these, like we didn't have great results, but despite this problem, we tried to plot all these values according to our visual analysis, because to have several measurements, we used the gloss meter, but it was for smooth surfaces, but we also tried to to classify them with our site. So we had different measurements and different classification. So here is the visual classification from the most matte to the most glossy sample with the peak width calculated with the second derivative.
So as a conclusion of our project, we have a portable imaging system adapted to irregular surfaces. By being dynamic in opposition with the gloss meter, which is fixed, it can deal with the grain of our sample and give us a satisfying classification. However, it remains a blur, an imprecision when it is up to the matte or strongly grainy samples. The classification is less precise, and the gloss scanner struggles to clearly differentiate each sample. To resolve this problem, it could be interesting in the future to push the analysis to each pixel instead of a small zone, and to optimize the MATLAB code used to compute the width of each curve. Thank you.